Welcome to the world of physics. In the name of Allah, the Beneficent, the Merciful. Due to coronavirus, we have to continue our online class. At first, I would like to suggest you to stay home, stay safe. Let me introduce. I am Mohammad Muqtadir Hossain Bhuiya, lecturer, Department of Physics. At first, observe this diagram and observe this diagram too. Now think what you have observed by this diagram and observe this diagram too, and think what you have observed in this diagram and what's happening in this diagram. Here, actually these are in this chapter we have one more lecture, and here the name of the chapter is Refraction of Light, and today we are going to learn about the topic that is explain the formation of image in concave and convex lens, and number 2, mathematical problem solution. And this is our last lecture on this chapter. At first, we are going to compare between reflection of light and refraction of light. That is, when incident ray is reflected from a surface, then the ray is reflected ray, and here the law is angle of incidence is equal to the angle of reflection. And in refraction, this ray is incident ray and this is refracted ray, and here incident ray is not directly equal to the ray of angle of refraction. And here we have two medium, that is air medium and water medium, and when the medium is changed, the ray went towards the normal or from normal. And here we go from rare medium to denser medium, that's why the refracted ray go towards the normal. And if the angle of incident ray is come from denser medium to rare medium, then the refracted ray will go from the normal. And here this is the difference between reflection and refraction. I think all of you know the difference between reflection and refraction. And let's discuss about lens and image. And here refraction in image, refraction in lenses. Actually, lenses are curved in shape and are usually of two types, concave and convex. All of you know about it. And convex lens is known as converging lens, and concave lens is known as diverging lens. Here, images are two types. One of them is real and another one is virtual. Lenses are used to focus light and form images, and here there are variety of possible types, and we'll consider only the symmetric ones. And the double curve and the double convex, that is double concave and double convex. Here this is a double convex and it is plano-convex. It is convexo meniscus or convexo concave convex, and it is concave meniscus, and it is plano-concave, and it is double concave. Here for a double convex, that is converging lens, the light refracts such that it converges at the focal point. Here F is the focal point, and here the convex lens, that is a double convex lens, act as a converging lens, and it converges in a certain point. And a double convex, that is a diverging lens, has a refracted ray diverge uh, as if they all come from a certain focal point. Here F is the focal point, and it seems to all the ray come from a focal point, that is F, and this ray is these are diverging rays, and this lens is concave lens or diverging lens. To construct a ray diagram, draw two of the three principal rays that is originating from the same point on the object and follows these rules. And the rules one is rays drawn through a point on the object and parallel to the principal axis, and here it refracted from through the focal point F. And rule 2 is rays drawn through a point on the object and through convex or concave the focal point, and here the refracted ray is parallel to the principal axis. And rule 3 is rays drawn through a point on the object and through the vertex, and here it goes straight through and doesn't change the direction as the aiming lens is thin. And these three rules can be drawn in this figure. And here the ray 1 is parallel to the principal axis and is go through the focus, and if the ray come through the focus, and it will refracted parallel to the principal axis. And our third rule is if it go through the vertex or optical center, then it will go straight in that way. And here we are going to draw some image type of converging lens, that is different image is from. And here convex lens is converging lens, and here 5 possible location. Case 1 is the object is located in front of F, and case 2 is the object is located at 2F, and case 3 is the object is located beyond 2F. And here case 4 the object is located between F and 2F, and case 5 is the object is located at F, and here F is the focal point. Is the 5 possible object location. Here please complete handout through a convex lens, that is front half. And here two examples are done for you, and the next slide to get started. And here case 1 is the object is located in front of F, and here the object is located in front of F, and we draw a diagram. Here we apply rule 1 and 2, and here the ray 1, and it goes through the focus, and here ray 2, it go through the optical center and go straightly in the same way. And after refraction it doesn't meet in a certain point, and if we draw certain lines in backward, and that it will meet in a certain point, and this image will be a virtual image. And here L stand for same side of the lens as object, and O stand for upright, and S stand for larger, and D stand for virtual. And note here the location, and which one is the location, the same side or opposite. And here we see that the at the same side we get the image here. And here case 2 is object is located at 2F. At the point 2F, here the object is, and we draw the line for we draw the line parallel to the principal axis, and it go through the focus, and ray 2 is go through the focus, and refractory is parallel to the principal axis, and ray 3 is go through the optical center, and it go in the same way in straight line, and it meet in a certain point. And here we get a image that is a real image. realized in the other side of the lens. And here try to solve this, and notice here that uh, the location and approximate location between which position, and you're also telling me that the side of the lens, the same side or the opposite, and I think all of you can guess where the image will be located, and the image is real or virtual. And I think all of you get the point that the image here, the image is real and in the opposite side. And our another example is another diagram for concave lens. And here concave lens is diverging lens, and object is located in a certain point, and we draw the ray diagram, and we got got the image from the ray diagram. Here three rows is if the rays come through the parallel to the principal axis, it go through in a point that it comes from a point that is focus, and if the ray is through the focus, and it will reflect in that way that the parallel ray that the refracted ray will parallel to the principal axis. And our final ray diagram is for if the rays come through the through the optical center, and it will go in the straight line. And here the three rule for diverging lens, that is for double concave lens. And by using this we can identify and we can draw the ray diagram for concave or convex lens. And here image is located between f and 2f, and the uh, object is image of an object is located between f and 2f and for a diverging lens. And here the image will be formed between optical center and the focus. And here this object and this image, and this image is in same side, and the image will be and here the image here the image will uh, image is virtual. And we just draw the line for we just draw the line for uh, draw the by using ray 1 and ray 2 and ray 3, and finally we got the image uh, for the object. And the image here, the image is virtual one. And this lens is diverging lens, and complete a ray diagram for converging and diverging lens. You need only to complete the 2 or 3 of this, and complete the summary table of image properties of diverging and converging side. And here the summary of the class is here: image characteristics formed by concave and convex lens. And here concave lens is diverging lens, and here the object location is arbitrary in any position. We get a image that is diminished and is it will be smaller than the object, and its location in between optical center and focus. And here the type is always virtual. By this way uh, we can write the every size attitude, location, and type of image for convex lens also. And uh, uh, try to try to write every size and attitude and location and type of the image for convex lens and for concave lens. If you can draw if you conclude all this information here, then it will be helpful for you to draw every diagram. And I think by this way you can solve nearly 50% of problem of this chapter. And today in next slide we are going to solve some mathematical problem. Here math 1 is what is the index of refraction um, in a medium where the speed of light is 1.5 into 10 to the power 8 meter per second. And here the solution is n equal to c by v, and here the refractive index is 2. And the next problem is what is the speed of light in water whose refractive index is 1.33. and we know n is equal to c by v, and by this way we can calculate the value of the calculate the value of the speed of light in water medium, that is 2.26 into 10 to the power 8 meter per second. And next question is a ray of light is incident through glass, and here the refractive index is 1.52 on an interface separating glass and water with refractive index 1.32. What is the angle of refraction if the angle of incidence of the ray in glass is 25 degree? And with help of a diagram we can explain, we can draw it as here the glass one is 1.52 and water medium refractive index of it is 1.32, and here the incident angle is for 25 degree, and here we have to, what is the angle of refraction, we have to calculate it as t, and from Snell's law we know that n1 sin theta 1 is equal to n2 sin theta 2, and here analogously we can write theta 2 as t, and by putting all this value from all this value we can calculate the value of t, that is angle of refraction. And the problem is, what should be the angle of incidence of light ray incident through air on the boundary separating air from water, so that the angle of refraction is 30 degree. And here refractive index of air is 1 and that of water is 1.32, and here air medium is refractive index in air medium is 1, and water medium refractive index is 1.32, and I is the angle of incidence and T is the angle of refraction. And here by using the law we know that from Snell's law we know that n1 sin theta 1 is equal to n2 sin theta 2, and by using this we can get the value of the angle of incidence from this equation, and here the angle of incidence is 41.3 degree. And here our next question is, a light ray strikes a homogeneous rectangular block and a block of glass of thickness W at an angle I, and here the ray emerges at the point B at the point B at an angle I prime, and we can see the diagram below, and with this diagram we can we have to solve three questions here. Question A is find I prime in terms of A and show that the emerging and the incident ray are parallel. And here the solution for one from Snell's law, at the point A we can write that n1 sin theta 1, n1 sin I is equal to n2 sin j. Here the in this diagram here the refraction angle is j, and here the incident angle is k, and the refractant angle is I prime. Just we write in the 2 point at the point A we write the we write Snell's law, and at the point B we write Snell's law, and here Snell's law at the point A, and here the Snell's law at the point B, and from these two law we can write that here the normal NA and V to the interface at the point A and B is they are parallel to each other, and therefore angle J and K are equal. Hence we can write this, and we finally got that I is equal to I prime, and here incident angle is equal to the emerging angle. Both the angles are same, and they are parallel to each other. And here second question is find the lateral displacement which is the distance d between the incident and emerging ray in terms of angle I. The refractive indices is n1 and n2, and the weight is W of the block, and we have to calculate the lateral displacement where the distance is which is the distance d between the incident and the emerging ray in terms of the angle I. And here we have given that the incidence angle refractive indices are n1 and n2, and the weight of the block is W. And here the solution, we have to calculate, we have to find the value of d here, and consider the right angle, that is ABO, and then we can write sine alpha, and considering triangle ABO prime, and we can write the angle J, and here alpha is equal to I minus J, and by putting this value of alpha in the first equation, that is first equation is sine alpha is equal to D by AB, and by putting this value of alpha here and substituting substituting the value, and then we can write it as sine I minus J is equal to D cos J minus W, and after that we can write D is equal to sine I minus J into W divided by cos J, and by using Snell's law, here the Snell's law is n1 sine I and 2 sine J, and here we can also write that J is equal to sine inverse n1 by n2 into sine A, hence we can write D is equal to by putting this value of J in the upper equation, we can write the value of D is equal to W sine I minus J divided by cos J, and hence we can write J is equal to sine inverse n1 by n2 into sine I. And here our last question is use the formula obtained at part B to calculate D, and here n1 is equal to 1 and n2 is equal to 1.55, W is equal to 3 centimeter, I is equal to 32, and we are going to calculate the value, and we have we are putting the value of n1 is equal to 1 and n2 is equal to 1.55, W is equal to n2 is equal to 1.55, W is equal to 3 centimeter, and angle of incidence is 32 degree, and all the values given, and we have to calculate the value by using the formula that obtained from B. And here the solution is we are given all the values here, and by putting all this value in the previous equation that we obtained from B, that is J is equal to sine inverse, that is arc sine is sine inverse n1 by n2 into sine I, and by putting this all the value, we get the value of J is equal to 20 degree, and D is equal to 3, that is here the equation is W sine I minus J I minus J divided by sine J, and by putting all this value from here we get the value of D is equal to 0.7 centimeter. And here our next question is what is the critical angle between air and water, and here the angle index of refraction of air is 1.003, and index of refraction, that is refractory index of water, is 1.33, and we have to calculate the value of theta 2 critical angle is when theta 2 is here for the condition of a critical angle is for a certain angle, the angle of refraction is 90 degree, and here the angle for a critical angle, the angle of refraction, that is theta 2, is 90 degree. The condition is here, and from Snell's law, we know that n1 sin theta 1 is equal to n2 sin theta 2, and here all the value is given, and we have to calculate the value of theta 1, and here by putting all this value, and here theta 2 is 90, and sin theta 2, that is sin 90, the value of sin 91, then we can write the equation is n1 sin theta 1 is equal to n2, because sin theta 2 is sin 90, the value of sin 90 is 1, and finally sin theta 1 is equal to n2 by n1, and by using inverse sign, that is theta 1 is equal to sin inverse n2 by n1, and here we put the value of n2 is 1.003 and the value of n1 is 1.33, because we have the value of angle refractive index of air is 1.003 and refractive index of water is 1.333, and by putting this value and by using calculator, you can easily obtain the value of theta 1, that is theta 1 is equal to 48.8 degree, and here theta is the critical angle, that's all, and here the critical angle between air and water is 48.8 degree, and all these That's all for today, and you may have some question, then you can ask me in our class time also. And there's a home task for you. Try to solve this, and I think it will be very helpful for you uh, for taking preparation for the exam, and try to solve this question. I'm going through, and here uh, a body is placed on a principal axis at a distance 20 centimeter of a lens of power 2.5 diameter diopter, and here what is called radioactivity, and number B question is a normal I can see a object of any distance, explain. uh, and number C is determine the distance of the image of the object. Here we the distance of the image we have to calculate here, and here the value of p is given and the value of u is given here, because distance of the object is given and the value of the p is here, and by using this here we know that p is equal to 1 by f, and by using this value of p we can get the value of f here, and here the value of u we have, and we know the equation, that is 1 by u plus 1 by v is equal to 1 by f, and from this equation we can determine easily determine the value of the distance of the image of the object, image of that object. And here the value of u is 20 centimeter, and by putting the equation p is equal to 1 by f we get the value of f, and by using the value of f and u we can easily get the value of v by and that's all. And there's a hint for you, and another question is which defect can be rectified with the help of the given lens, and here uh, we have to we have to draw the ray diagram also here. With ray diagram we have to explain, and here I am giving you some hint is that here the question is which defect can be rectified with the help of the given lens, and here the given lens power of the given lens is 2.5 diameter, sorry 2.5 diopter, and here the plus sign indicate the lens is a convex lens, and we know that by using convex lens we get we can solve the problem, or solve the problem, and we can here if the problem is far side, then uh, if you have any problem to see any object in the outside, then we use convex lens, and to solve the problem in far side we use convex lens, and the power of the convex lens is negative, and the power of the concave lens is negative, and the power of the convex lens is positive, and here the power of the lens is positive, that's why the lens is convex lens, and by using convex lens we get we will be able to solve, or we will solve the problem or the defect of eye which having near sight problem. And last but uh, not least, we have to be careful when we go outside, and thank you all for joining with us, and Allah Hafiz.